We build our lives on the foundation of permanence. We assume the ground beneath our feet and the blue sky above are eternal constants. But the universe promises only one thing change. The Earth is not a fortress. It is a vessel, drifting through a hostile void protected by a thin veil of atmosphere and the precise temperament of a middle-aged star. Most believe the end will come in fire, infuriate an asteroid, impact a nuclear winter, or a sudden solar flare. But the true end of the Earth is far more insidious. It is a slow, quiet suffocation. To understand the end, we must first analyze the engine that drives our existence. The Sun is not a static ball of fire. It is a dynamic, evolving star in the middle of its life cycle known as the main sequence. Deep within the solar core, hydrogen atoms are crushed together to form helium. This fusion releases energy, the light and heat that bathe the Earth. But this process leaves behind ash in the form of helium. As the helium ash accumulates, the core becomes denser and hotter. To maintain equilibrium against the crushing weight of its own gravity, the Sun is forced to burn its remaining fuel faster. The result is a steady, inexorable increase in brightness. For every 100 million years that pass, the Sun's luminosity increases by approximately 1%. This number seems trivial. In the context of a human lifetime, it is undetectable, but for a biosphere, it is catastrophic. We rely on a delicate planetary thermostat called the carbonate silicate cycle. Volcanoes pump carbon dioxide into the atmosphere, keeping us warm. Rain washes that carbon out of the air and binds it into rocks, cooling us down. But as the sun brightens, the heat increases. This accelerates the chemical weathering of rocks. The rain becomes too efficient. It scrubs carbon dioxide from the atmosphere faster than the volcanoes can replenish it. The planet is not overheating yet. Instead, it is being starved. Plants require a minimum threshold of carbon dioxide to perform photosynthesis. We are approaching a point where the atmosphere will no longer support complex plant life. This is the irony of our demise. We fear the fire, but the first blow will be struck by the chemistry of the air. When the plants die, the oxygen supply fails. The food web collapses from the bottom up. The silence begins not with a bang, but with a gasp. Fast forward 1 billion years. If you were to look down from orbit, the familiar blue and white marble is gone. The continents are no longer defined by the green of forests or the yellow of deserts. They are a uniform, lifeless brown. With the biosphere collapsed, oxygen levels plummet. Ozone, our shield against ultraviolet radiation, dissolves. The surface is now sterilized by the sun's unfiltered glare. But the greatest transformation is happening in the sky. As the solar luminosity climbs by 10%, the atmosphere heats up. We enter a phase scientists call the moist greenhouse. The stratosphere becomes saturated with water vapor, which is normally trapped low in the atmosphere by cold temperatures. High above the surface, water molecules are exposed to harsh solar ultraviolet light. They are ripped apart in a process called photodissociation. The oxygen stays behind, binding to the rocks and rusting the surface. But the hydrogen is light. It escapes Earth's gravity and flows into the cosmic dark. The Earth is not boiling. It is bleeding its oceans into space drop by invisible drop. Without water, the planetary engine grinds to a halt. Water acts as a lubricant for plate tectonics. As the oceans dry up, the crust seizes. Volcanoes fall silent. The recycling of Earth's crust stops forever. The world is now a vast salt-crusted wasteland. There are no clouds, no rain, only the relentless wind and a blinding, swollen sun. It is a silent tomb waiting for the final act. 5 billion years from now, the hydrogen in the solar core is finally exhausted. The delicate balance between gravity pulling in and energy pushing out is broken. The core collapses under its own weight, heating up frantically. This collapse ignites a shell of hydrogen around the core. The sudden surge of energy pushes the outer layers of the star outward. The sun begins to swell. It turns from a blinding white to an angry deep red. From the surface of the dead Earth, the view is terrifying. The sun no longer sits in the sky. It consumes it. It grows 200 times wider, stretching from one horizon to the other. Temperatures on Earth soar to over 2,000 degrees. The rocks do not just melt, they vaporize. The atmosphere is stripped away entirely. The mountains, the dry ocean beds, the fossils of our civilization. Everything returns to a molten magma ocean. Physics offers two paths. As the sun expands, it loses mass, loosening its grip on the planets. Earth might drift outward, becoming a burnt cinder orbiting a dying star, or the drag of the sun's outer atmosphere will catch us. If that happens, the planet spirals inward. It plunges into the stellar furnace and dissolves. The atoms that once made up our bodies, our cities, and our history are scattered back into the cosmos. Total entropy. But this is not a tragedy. It is a cycle. The death of a star plants the seeds for the next generation. The heavy elements cooked in this furnace will eventually form new nebula, new stars, perhaps even new worlds. We are temporary, but that is exactly what gives this moment value. Look at the world around you today. The blue sky, the liquid water, the green leaf. It is a statistical improbability. We are not witnessing the normal state of the universe. We are living in its brief golden miracle. The earth will end. The sun will die. But right now we are here to see it shine. And that is enough.